So we're going to talk about reciprocal functions. This is day 3 of lesson 22. Now, first thing we're going to talk about today is what is an asymptote. You guys should have seen asymptotes or heard about them in Algebra 2 because you graphed things probably similar to this at one point. Eric?
They're a line that continues very, very, very close to zero and never equals zero.
Okay, that is the properties of what happens to an asymptote. The asymptote is the line that it approaches. So this is what we're going to call a line that a graph approaches but never touches. And then I'm going to put in parentheses here, at the ends. What I mean by that is that, because in math a lot of times we come up with a rule, and then all of a sudden, well, 10 lessons later, we go and say, hey guys, remember that rule from like last month? We're going to break it today. Because in math we break rules that we establish sometimes. Now, it matters what kind of asymptote we're talking about. We're talking about vertical, horizontal. Now, when we're talking about these asymptotes, and I say at the ends, it's because it's the end behavior of a graph. It's going to say, as the graph goes to infinity, or positive infinity, or negative infinity of x, where is it going for the y's? It can follow a line. Okay? So, if I had a graph on the bottom here, and I had an asymptote across there, what it means is that the graph can be coming from the bottom, but it would have to curve left or right, and it's going to approach the asymptote. It will not touch or cross it. That's what we're trying to say. That's at the ends. That as the graph keeps going further and further and further away, it gets closer and closer and closer, like Eric was saying. The dotted line is the asymptote. Asymptotes are not part of your graph. If I was to graph something with an asymptote, or more than one asymptote, you would not see the dotted lines on there. It's like this invisible force that's pushing or pulling a certain type of graph one way or the other. Okay? When we make our sketches, or our graphs, we put them on there so we can actually say, hey, it should be doing this when it gets here. Okay? So, vertical asymptotes, these ones will never be crossed. You might jump over the line, but you can't cross them. And that's because it does what? You get a vertical asymptote where something is equal to 0. And it happens to be the bottom of a fraction. And we would say that is the denominator. If the denominator is 0, or equals 0, you can't divide by 0. And so it creates this vertical line that you can't touch. You can jump over it. There's ways later on we'll show that you're going to jump over it and not touch it. Okay? But that creates a vertical asymptote. We also have horizontal asymptotes. It's in the green there. For our graphs that we have today, you're only going to have a horizontal asymptote at 0. It's not going to be moved yet. We will move them eventually. There are 3 cases of a horizontal asymptote. And it follows the case of the degrees of the top and bottom of a fraction. If the degree of the bottom is higher than the degree on the top, like our example here of 1 over x, it's going to be y equals 0. If the degrees are the same, so like I had 2x plus 3 on top and x minus 4 on the bottom, the degree of the top and bottom are 1. I can actually take the coefficients in front. Again, we'll go over this later, but I'm just kind of giving you a heads up that then it's just the coefficients of, I think it was 3 and the 1, so it's 3. So it would be y equal 3. So it can move there. And there's a third case when the top degree is bigger than the bottom degree. So I'll say you have a quadratic divided by a line. Right? Or something of the first degree. Therefore, I have to use long division and find the resulting polynomial. That polynomial is the line that it will approach. Okay? So there are 3 cases. We're dealing with case number 1 It's always going to be y equals 0 for us, okay? So, if you follow those 5.5 steps or 6 steps, however you want to look at that, find your vertical asymptotes, aka set the bottom equal to 0. I have that right there. Find the x-intercepts. Set the top equal to 0 and solve for x. Find the y-intercepts. Wait a minute. Y-intercepts, x-intercepts. For the y-intercept, plug 0 in. Because, wait, this one's easier. All y-intercepts have what for x? 0, right? 0, comma, something, y, right? 0, 4 means it's on the x or y-axis at 0, 4. X-intercepts all have a number of x, comma, what's y? 0. Okay, so be mindful of that. 4, create some t-charts. And then 5, draw your curves in. If you can remember those 5 things, these are simple. It may take a little bit of thought process when you get to your t-charts, but the rest of it really isn't too bad. So our first example we'll do together is the example that I kind of had of representation of what a reciprocal function is, or a fractional equation, or a fractional function. Y equals 1 over x. So I go back to my list. What are those things I'm trying to find? First thing, vertical asymptote. The vertical asymptote said what? Those rules, guys, were for all rational functions. They were not for any particular one. So you can use them over and over and over and over again. What do the rules say? Set the bottom equal to what's in the bottom? It's x. So x equals 0. Where do you think the vertical asymptote is? X equals 0. Wait, what is x equals 0 on a graph? It's a vertical line. Vertical asymptote. Same thing. Now, we go to our horizontal, right? Horizontal. The horizontal said all of our problems right now, the bigger is the top, the bottom's bigger than the top, so it's just y equal 0. Then we go into x-intercepts. X-intercept said set the top equal to 0. 1 equals 0. That doesn't make sense, does it? That can't be, so the answer is none. There's no x-intercept. Now wait a minute. Wait a minute. If the horizontal asymptote is y equals 0, the vertical asymptote is x equals 0, well, aren't those just the axes? And if I can't be on the axes or touch the axes, therefore I should have no intercepts. So let's check that y-intercept out just to make sure that's true. It says plug 0 in, yes? So y equals 1 over 0, and I can't do that. So therefore, none. At this point, you gathered all of the information before setting up your t-charts. So now I'm going to create a graph. Try to be as consistent as possible. I see that I wasn't too consistent. And I'm going to change colors. I highly suggest that you guys use a lighter, darker style if you got only one color, or change colors if you want. I'm going to draw my vertical and horizontal asymptotes in. I think most of us would say x equals 0 should be right there, right? At x equals 0. Y equals 0 is the x-axis. I can't cross those, technically. Right? Don't have to plot any points because I don't have any yet. Step 4, I think it was on that list, said, now create t-charts. The dotted lines are the asymptotes. They're not really part of the graph. So technically, if you were to graph it on a graphing calculator or a graphing apparatus, you would not see the red dotted lines. They just wouldn't be there. You would just see the graph that's going to result from it. Now, what does it mean by make t-charts? Well, here's the thing. When I'm thinking of t-charts, I'm thinking of putting what into t-charts? Numbers. But those numbers actually stand for which variable? X. To get y's out, right? So I am going to choose my x values. If I'm looking at this graph, there is one particular x value I could not be. What is it? 0. So the domain is all but 0, right? All real numbers but 0. That dotted line at 0 breaks the graph into two areas, a left side and a right side. So guess what? How many t-charts am I going to make? 2. If there was another vertical asymptote, so we're going to take this out. Say there was one here too. How many different areas of x's are there now?
3.
There's 3. Far left, far right, and the ones right down the middle. Okay? So don't do that, because that one doesn't have it. Just showing that for every vertical asymptote, you add one more t-chart. Then all I'm going to do is pick x values around that vertical asymptote, but going in the opposite direction. I can't put 0 in, so on the left side I'm going to put -1, -2, and -3. And on the right side, or right side, 1, 2, 3. Again, choosing values around it. The bigger a number I put in, probably the bigger or smaller number I will get. So generally choose close to 0 if you can. Not always an option. So now I take those x values and place them back into the original problem. So what's 1 divided by -1? -1. What's 1 divided by -2? -0.5 or -1/2. And put -3 in. -1/3. Is everybody okay with that? Moving on. Hopefully no calculator needed. 1 divided by 1. 1 divided by 2. 1 divided by 3. Okay? Pretty simple. Can you plot those on the graph? I hope so. They're a set of points. Where's -1, -1? All right there. -2, -1/2. Somewhere about there. And -1/3. -3, -1/3 is about there. Those points look like they're kind of going in a row, but they're really not. I don't have a perfect graph here. But they should be curving. Now, as we can see that we have, well, let me recircle that. We have these 3 points, yes? If I start with the middle point, and I'm going to the left, and I can't touch or cross that dotted line, my only recourse is to curve up just a little bit, yes? And if I go the other way, I'd have to curve that direction. I'm going to approach it, but I'll never touch it. Going kitty corner. 1, 1. 2, 1/2. 3, 1/3. And so what does this look like? Boom. You just have a graph. You are done. The dotted lines are not really part of the graph. This is called a hyperbola. Now, this one is y equals 1 over x squared. I want you guys on your own. I'll come back to the video. I want you to find the 4 pieces of information on your own. So, we need vertical asymptote, which would be x squared equals 0. We need to have a horizontal asymptote at y equals 0, right? I'm just putting some information down. We'll go back and solve these things. This is what I'm thinking. This is my process of how I'm going about this. x-intercept, set the top equal to 0. 1 equals 0, and y-intercept we say is y equals 1 over 0 squared. Takes all about 10-20 seconds to write all of that down. Then we go back and we can start to decode some of it. When is x squared equal 0? There's only one time when you square it and it is 0, and that is 0 itself. Horizontal asymptote is at 0. We talked about that already. You can't have that, right? You can't have 1 equals 0. None. And, again, dividing by 0, none, right? It's almost the exact same setup as last time. So far. So, put our axes in. Let's put our asymptotes in. I'm changing colors. X equals 0. Y equals 0. Okay? No intercepts. How many t-charts? Not 0. 2. I got how many vertical asymptotes? I've got 1 vertical asymptote. Add 1 more. Now you got 2 t-charts. What values again am I going to put in? 1, 2, 3, negative 1, negative 2, negative 3. Now, if it's easier, guys, to think of when you're doing this in your head, you can write them down. Don't get me wrong. Write them down if you need to. But if you need to, think of, because the only thing that's happening is in the denominator. Work the denominator out in your head and then divide it into 1. Negative 1 squared is 1. What's 1 divided by 1? 1. Negative 2 squared. 4. 1 divided by 4 is 1/4, or 1 divided by 4. Negative 3 squared. 1/9. 1 squared. That's not a negative. That was some leftovers. It will be the same thing. There's just 1. 1/4, and it's the same thing. Now this is kind of cool, recognizing, guys, that I'm squaring the number on the bottom and not doing anything else. So it doesn't matter if it's negative or positive that goes in. It's the exact same thing. It's going to be reflected about the x-axis. It's got a reflection. So let's go graph it. 1, 1, 2, 1/4, and then goes down to 1/9. Gets pretty small pretty quick, huh? And we know that it should look like this. And hey, the negative side also starts at 1, goes down and goes down. So it looks like that. They're standing next to each other. But that's the power of squaring numbers, making them positive again, doing stuff like that. So on this problem, I've changed it a little bit. Things have changed. Now we have a 2 on top instead of the 1. Guys, it's a constant. It doesn't matter. Okay? If it ended up being something with a variable, then you could actually have x-intercepts. It's okay. Now, vertical asymptote, it says set the bottom equal to 0. That's x minus 3 equals 0. Horizontal asymptote, we said it was always going to be y equals 0 for now. My x-intercept, 2 equals 0, and y-intercept is plug 0 in. 2 over 0 minus 3. Yes? All within 20 seconds, you guys can write it all down, get it out of the way, and then go back and clean it up. When does x minus 3 equal 0? When x equals 3. Does 2 ever equal 0? None. And, wait a minute, we have a y-intercept this time, guys. What is it? What?
2/3.
It's not 2/3, but negative 2/3. Now, wait a minute. If I actually tell you an x-intercept and y-intercept, I'm I'm not talking about x equals or y equals, because x equals and y equals are lines. If I want to know an x-intercept, I actually need to know the point. What is the point associated with y equals negative 2/3? What did I put in? What's the x value? 0? It's 0, negative 2/3. That's the official point, because that's the point of the y-intercept. All y-intercepts have 0 comma something. All x-intercepts have x comma 0, right? So be careful on that. And then we can graph. Bless you. That's a smaller graph, I guess. Changing my color here. X equals 3. It's not the y-axis anymore. It's over here, isn't it? I think I should probably make that graph a little bit longer now. Okay. And y equals 0. And we do have a point. 0, negative 2/3. Somewhere about there in there, huh? How many t-charts? 2. One over here and one over here. Now, if I had given you guys a quadratic in standard form, ax squared plus bx plus c, and I asked you to graph it, would you guys just revert back to your Fab 5 and put negative 2, negative 1, 0, 1, 2 in?
Yes.
I hope not. Because what does a parabola look like? Guys, a parabola is this shape, right? A U shape?
Yeah.
And if I only choose values on one side, it'll look like that, which is just like a line, right? You might not see the whole parabola. The whole idea of finding a parabola was to find that center point so you can get the bottom of the curve, right?
So would you use like
So you get, well, you'd have to use that negative b over 2a to find the x value. And that x value might be at 100, it might be at negative 2. But then you chose values around that center, right? The same thing here, guys. I've got this vertical asymptote at 3. I'm going to choose values around 3. I'm not going to choose values between negative 2 and 2, because that's only half of the graph over here. I need both sides. So, what values am I going to place into the left t-chart? 2, 1, and 0. Staying close to the asymptote and moving away. Going on the other side, I'm going to choose values like 4, 5, 6. Hey, and we know 0. If I put 0 in, what's coming out? Negative 2/3. That was our y-intercept. So if I can put my y-intercept as one of my points, I'm happy. And again, this is where I'm going to work on this one step at a time. I'm going to do the denominator first and then divide it into the top. What's 2 minus 3? Negative 1. So it's 2 divided by negative 1. It's negative 2. What's 1 minus 3? Negative 2. What's negative 2 divided by negative 2? Negative 1. We now just completed the left-hand table. Let's go to the right-hand table. What's 4 minus 3? 1. And what's 2 divided by 1? 2. What's 5 minus 3? What's 2 divided by 2? 6 minus 3 is 3. And 2 divided by 3 is 2/3. And now I can go back to my graph. And I can plot my points. -2, -2. -1, or 1, -1. Oops, wrong place. Should be there. So I hope everybody agrees that my graph will be in the bottom left-hand corner for one side. And the other side at 4, 2, 5, 1, and 6 2/3 goes in the top right corner. You're done. Follow the simple rules. This should not be bad. Okay? This is your homework, lesson 22, day 3. We finished it up. I want you to do y equals 4 over x minus 2, y equals -2 over x squared, and y equals 3 over x squared minus 9. Number 3 is a tricky one because there's more than one vertical asymptote. Have a great day.